You know, we've sent messages in bottles across oceans for centuries, but what if the ocean was the entire cosmos? Well, today we're diving into NASA's Voyager mission, which is pretty much humanity's most incredible message in a bottle, sent on an epic journey to the stars.
It all starts with one of the biggest questions we can ask, right? Are we alone out here? That single, powerful question is really at the heart of the Voyager program. It's not just about seeing what's out there, it's about reaching out, about saying hello into the dark on the off chance someone is listening. So picture this. It's 1977 and NASA launches these two twin probes. Now they had two jobs. The first one was to be our robotic eyes and ears on this amazing grand tour of the outer solar system. But their second job, the much longer one, was to become interstellar ambassadors, carrying a greeting from all of us here on Earth.
But why 1977? I mean, why then? What made this unbelievably ambitious mission even possible? Well, it all came down to a little bit of cosmic luck and some absolutely perfect timing.
So back in 1965, an engineer at NASA noticed something incredible. The giant outer planets, we're talking Jupiter, Saturn, Uranus, and Neptune, were lining up in a way that only happens once every 175 years. This wasn't just some cool celestial event. It was the one and only launch window for this epic journey. And the key to the whole thing was this brilliant move called a gravity assist. Honestly, think of it like playing a game of cosmic pool. By aiming the probes just right, they could use the massive gravity of each planet to slingshot themselves toward the next one, picking up speed as they went. This trick saved a ton of fuel and literally shaved decades off the travel time. Without it, the Grand Tour, it would have just stayed a wild dream.
And here was the game plan. After launching in '77, the probes would start their interplanetary hopscotch. First up, Jupiter in '79. From there, they'd slingshot over to Saturn. And then, Voyager 2 would keep going, becoming the first spacecraft ever to visit Uranus in '86 and then Neptune in '89. Just an incredible, perfectly planned journey across the solar system.
Okay, so the probes are on their way. Let's get to the good stuff. What did they actually find as they journeyed through this realm of giant planets? First stop, Jupiter. And what Voyager found here completely flipped the script. It didn't just send back cool pictures, it sent back some real shockers. For one, Jupiter had rings. We always thought that was just Saturn's thing. And its moon Io, it was covered in active, erupting volcanoes, the first we'd ever seen anywhere besides Earth. It was a dynamic, totally surprising place. Next up was Saturn. And while, yeah, it found new moons and gave us these incredible views of the rings, the real star of the show was one of Saturn's moons, Titan. Voyager's data showed that Titan is the only other place in our entire solar system with stable lakes and rivers on its surface. Now, it's not water, it's liquid methane, but still, what a discovery. It was a total game changer.
So, after visiting Saturn, this is where our two explorers split up. Voyager 1's main job was done. It used Saturn's gravity to basically fling itself up and out of the flat plane where all the planets orbit and started its long, lonely trip out to the stars. But Voyager 2, it kept going, becoming the first and, get this, still the only spacecraft to ever visit Uranus and Neptune.
And this is where the mission enters its next, even bigger phase. This is the story of the journey into that vast, quiet emptiness between the stars.
Years after it left the planets behind, on Valentine's Day in 1990, NASA gave Voyager 1 one last command. They asked it to turn around and take one final picture of home.
And the distance from which it took that photo is just mind-boggling, 6 billion kilometers. To put that in perspective, light from our sun takes more than 5.5 hours to travel that far. From that incredible distance, it took a final family portrait of our solar system. And in that portrait, our home, Earth, showed up as just a single pixel, a tiny, pale blue dot, just hanging in a sunbeam. Carl Sagan, who pushed for this photo, said it best. It's such a humbling image, showing our world not as this huge place, but as this tiny, fragile speck in a vast cosmic arena. After that last photo, the cameras were powered down for good to save energy for the really long trip ahead. And boy, was it long. It took another 22 years for Voyager 1 to finally cross the heliopause. That's the invisible bubble our sun blows around the solar system. In 2012, it officially entered interstellar space. Voyager 2 followed a few years later in 2018. They are still the only things we've ever built to make that crossing. And its journey just keeps going. As of late 2024, Voyager 1 is a jaw-dropping 24.7 billion kilometers away from us, and that distance grows every single second.
It is, by far, the most distant object humanity has ever created.
But, discovering new things about planets was only half the mission. Let's talk about the other half, that incredible message it's carrying for us.
Bolted to the side of each probe is this beautiful piece of hardware, a 12-inch gold-plated copper record, the Golden Record. It's basically a time capsule, our message in a bottle, designed to tell any potential finder the story of our world.
So, what did we send? Well, it's an amazing collection. There are 115 images showing everything from the structure of DNA to kids playing. It's got spoken greetings in 55 different languages, an incredible playlist of music from all over the world, and just the sounds of Earth. Wind, rain, whales singing, a train whistle.
But wait, how would anyone see these pictures on a record? Remember, this was 1977. In an absolutely brilliant move, the engineers converted each picture into sound waves. The instructions on how to turn that sound back into an image are etched right onto the cover of the record itself. It's like a cosmic Rosetta Stone, a huge puzzle, but with the solution included.
What's just as important as what's on the record is what they left off. There are no pictures of war or poverty or anything negative. The team, led by Carl Sagan, made a very deliberate choice to show an idealized version of us. It's a highlight reel. It's not just about who we are, it's about who we hope to be.
Sadly, though, the active part of this mission is coming to an end. The plutonium generators that have powered these probes for almost half a century are slowly running out of juice. Scientists figure that sometime around 2025, we're probably going to lose contact with them forever.
But here's the amazing part. Even after they go silent, their journey is nowhere near over. The probes themselves will just keep drifting through the Milky Way for millions, maybe even billions of years. They'll be out there, carrying that golden record long after our civilization might be a distant memory. They are our silent, eternal messengers. Which, of course, leaves us with that one last huge question. After floating through the darkness for ages, will our message in a bottle ever actually be found? And if it is, what will they think of us?